Hi, so this is the problem continued. We've got a second question. What are the concentrations in molarity of lanthanum, oxalate, sodium, and chloride after the reaction is complete? Please find the moles and divide those by the total volume. So you've got 4 species that you need to calculate the concentration of. So if you've got a limited amount of time, you've got to use your time as best you can. The first thing you should write down is the concentration of the limiting reactant species. If we remember last time, the lanthanum chloride was the limiting reagent or limiting reactant, and the lanthanum specifically was the limiting reactant because it did it. So you should, first of all, that should be your first step, right? That takes 5-10 seconds. You know it's 0 molar. You don't need to calculate anything. You write it. All right, then you got let's say you got 1/4 of the points. Next you find the concentration of the spectator ions. For the spectator ions, their concentration the number of moles of each spectator ion doesn't change. Concentrations do. So you start off with this volume of sodium oxalate. You convert to moles of sodium oxalate. You have a fraction for converting to moles of sodium. 1 mole of sodium oxalate gives you 2 moles of sodium. That's enough. Figure out the number of moles of sodium. Right, we got moles of sodium. That's not a concentration, but if we can use this to find concentration. See, that doesn't take long, 15 seconds. Next, you do the other spectator ion, chloride in this case. So we do this volume of lanthanum chloride to this many moles. 1 mole of lanthanum chloride contains 3 moles of chloride ions. So you write that and then you calculate. Okay, so we have moles. We can double check everything and make sure we did our math right. Everything's written out on the paper. We're showing how we proved this. And then we're going to divide both of those by the final volume to get molarity. So right, it was 30 milliliters added to 25. So your total volume is 55 milliliters. So we do moles divided by 0.055 liters. Box around it. So okay, now we've got a concentration of sodium when the reaction's finished, a concentration of chloride when the reaction's finished. That is 3 out of 4. So if you're running low on time and you're doing a problem like this, quickly answer those because that's maybe 5 minutes and that's 3/4 of the points. The hardest one is the excess reagent, right? So we used oxalate. Some of it was consumed, but not all of it. So, back. I can actually use the same things I've written. So we go volume of sodium oxalate to moles. This is so if I stop there, this is just the number of moles of oxalate that were present before the reaction. For the bottom, I gotta change this. I have moles of lanthanum. Oh, look at 1 mole. So 1 mole of lanthanum 3 chloride has 1 mole of lanthanum 3. 2 moles of lanthanum 3 react with 3 moles of oxalate. Let me calculate. Why did I use a calculator for that? Next one. So we have 0.00600 moles of oxalate initially. We consume, keep in mind that's what this is. We're talking about the amount of lanthanum that reacted with oxalate. So this is the amount that's consumed. It's kind of set up nicely. I just need to subtract these. If I subtract these, I'll have the amount of oxalate that is left in the solution. Which is not the answer. The answer, to get the answer, I need to divide by the volume of the solution, which is still 55 milliliters. So divide that. Six point nine times 10 to the negative third. That's the concentration of oxalate.